Hi everybody. Let's look at some algebra now for our preparatory exercises before we start the term, just to remind us of some of the stuff we already know. So, distributive law. Take the expression outside the bracket, multiply it by everything inside the bracket. So in this case we get a times b and a plus a times c. If we have a whole bracket on the outside, take this bracket, multiply it by that bracket, we'll end up with a times c plus d, here it is here, plus b times c plus d there. And then we continue with a times c plus a times d as per distributive law above, and bc plus bd. Null factor law assists us with a lot of our solving of equations, and the idea here is if we have ab equals 0, then for that to be true, either a has to be 0 or b has to be 0, or both of them have to be 0. The difference of two squares property. If we have two expressions, or two terms in this case, x squared take y squared, that will always expand to x take y, x plus y. And if we look here at an example, we're just expanding 4 brackets x plus 3 take 3 bracket x plus 2. That gives us 4x plus 12, here it is here, take 3x take 6, which is this here. Collecting like terms, 4x take 3x gives us x, 12 take 6 gives us 6. Expanding this expression here, x times x plus 1, negative 7 times x plus 1, there it is there. X times x gives me x squared, x times 1 gives me x, negative 7 times x gives me negative 7x, negative 7 times 1 gives me negative 7. Simplifying this, x squared takes 6x, takes 7. There it is there. Factorizing, going backwards from an expression to a bracketed expression. So what's the common factor between 21x and 7? That would be 7. To put that out the front, 7 times 3x gives me 21x, 7 times 1 gives me 7. In this case, we've got 3 terms. What's common to them? 6 and p. Put that out the front. 6p times 2ay gives me 6apy. 6p times 2yz gives me 6pyz. 6p times negative aq gives me negative 6apq, as required. Monic trinomial. Monic because it hasn't got a value greater than 1 in front of the x squared term. In this case, we want to factorize it, so we're looking at the factors of negative 7 that add to negative 6. In this case, it'll be negative 7 plus 1. Take the factors, put them in the brackets, away you go, nicely factorized. Difference of two squares, x squared is a squared term, 3 squared is also a squared term. In that case, that will always factorize to x take 3, x plus 3. Easy done. More difficult case, 16x squared take 225y squared. 16 is a squared term, 4 squared. 225 is a squared term, 15 squared. Will give us a pair of squared terms, a pair of terms I should say. 4x take 15y, 4x plus 15y. And if you expand this, you'll end up back to this. Solving equations. To solve an equation, make the unknown the subject, take everything else to the other side. In this case, we end up with 2x on this side, take the 4 to the other side. 15 take 4 will give us 11, 2x equals 11, divide both sides by 2, x equals 11 over 2. Here we have some simultaneous equations. We could use substitution or elimination method. In this case, I did it over here because I was running out of space. And we used elimination method. We can eliminate the y's. I named 5x take 2y equals 6 the first equation, 3x plus 2y equals 26 the second equation. Added them together, the y's became eliminated. We were left with 8x take equals 32. Divide both sides by 8, we get x equals 4. Substitute x equals 4 back into one of these two equations. I think I did the second equation, which gives us 3 times 4 plus 2y equals 26. Subtract 12 from both sides, you get 2y equals 14. Divide both sides by 2, you get y equals 7. The solution for that simultaneous equations problem is x equals 4, y equals 7. and you should be able to do the other method as well. Now we can also solve equations using null factor law. So in this case, if we're going to use null factor law rather than just taking the square root of both sides, we would subtract 25 from both sides, factorize it by difference of perfect squares, or difference of two squares. So x squared take 25 is the same as x squared take 5 squared. So that'll factorize to x take 5x plus 5 and give us two solutions where x take 5 equals 0. So for that to be true, x would have to be 5, or x plus 5 equals 0. For that to be true, x would have to be negative 5. Here's a second case of that. So we have 2x take 3 brackets x plus 1. We would need 2x take 3 to be 0 or x plus 1 to be 0. So here's the 2x take 3 example. Add 3 to both sides, divide both sides by 2, you get x equals 3 over 2. For the x plus 1 to be 0, subtract 1 from both sides, you get x equals negative 1. In the next case, we would factorize the trinomial and then use null factor law to solve it. Factors of negative 20 that add to negative 1, that would be negative 5 and 4, giving us two solutions of x equals 5 and x equals negative 4. And similarly, we can do it for cubics. If we have it in factored form, that would have to be 0, or x plus 1 would have to be 0, or x take 5 would have to be 0 to make the whole equation 0. So that gives us three solutions: x equals 0, x equals negative 1, or x equals 5. Now we could do this same problem, any of these problems, on our calculator. The easiest way is to put the equation in on the top line, hit return, then go solve the previous answer, comma x, and as we can see here, we get x equals negative 1, x equals 0, x equals 5. This is often better than just putting that equation where it says answer, because that can get a bit messy, especially as it starts to go off the edge of your calculator screen. And that's a bit of review for you. I hope that reminded you of some of the stuff you learned over the last couple of years. Thank you, everyone.